this is HVAC design. However, this HVAC design, this type of design is VRF, and VRF means that one outdoor to many indoor. The ones we've been doing before is one indoor, one outdoor. That is, one indoor is connected to one outdoor. That's the split system. So that one, the load is just direct. You calculate the load for the indoor because it's the indoor that is powering the outdoor. But in this case now, the outdoor is being powered separately, and the indoors too is being powered separately. So we have to calculate the power consumption for the indoors. Then we also have to calculate the power consumption for the outdoors. So now, first understanding this here, as you can see, this is our outdoor, and you will see a line connecting all of these people. So what it means is these are indoors. What type of AC is this? No, I'm not saying brand. Which one should we believe? Oh yeah, fully mounted. The first part. What's the full meaning of CCU? Good. If you say ceiling mounted, okay, good. There are so many type of AC that are mounted on the ceiling, so it doesn't really give us a specific type of AC we are talking about. This is ceiling cassettes. Ceiling cassette. That's the one you see most in banks. Variable refrigerant flow or volume. So that's it. Now relating the report with this diagram now. You know, on the normal stuff, this person wants to give us details. Like you will have put the code, like this outdoor, this is the code and the like. However, I can easily decode. If you look at this now, we have how many indoor on this outdoor? 1, 2, 3, 4, 5, 6, 7. So let me go back to my report. Can you see that? This is games room. So just to identify it. So let's go here. I've already pasted it here. So just to so I know that this is my games room. So if you look at these two, this is my outdoor, right? It's connected to this ceiling conceal unit. As you can see, these are slot diffuser. That's where the cooling is coming out. This is one. Then it moves to this, connected to this guy, and connected to this guy. So how many indoor do I have on this outdoor?
How many indoors?
Yes.
1, 2, 3.
That's three. Samuel, why do you say one? So can you say 1, 2, 3? That means this is it. So let me I mark it. So on a normal stuff, the person will have put the code there. And so you don't need to be doing all these things just for the sake of explanation. So definitely, if you look at this guy, can you see that these are the two in one? We have it like this. It's connected to this. 1, 2, come there, 3, 4, 5. So if we check it, okay, that's the first one. 1, 2, 3, 4, 5. Cool. So this is my restaurant, blah blah blah. So now, okay, good. Now let's now quickly talk around as electrical per se. Let's now talk around circuiting aspect. Now, let me quickly explain stuff like this is in line of electrical, blah blah blah. You know, this indoor and outdoor, they are like one equipment. What I mean by they are like one equipment is that, okay, as I said earlier, this guy, these indoors, they are going to be powered separately. While this outdoor is going to be powered separately. Unlike split system, whereby we just power the indoor and the indoor will automatically power the outdoor. Now, if this guy is going to be powered separately and this guy is going to be powered separately, that means their power must come at the same time for this thing to work. Because if you power this and you don't power this, it can't work. So that's why I said that, okay, they are like a single unit. Now, so this is how we do it. This indoor, they consume very, very minimal power. And they are single phase. Now, everything I'm explaining is based on VRF. Now, this indoor, they are single phase and they consume very small power. So therefore, so that this indoor will be power at once, bam, they are going to be on the same circuit. So now, if I'm circuiting this AC now, let me go to my. So if I want to circuit this AC now, that means this one will be DP12. 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 You get it now. So if I want to circuit this guy now, this one will now be DP13. This one also will be DP13. This one also will be DP13. Mind you, earlier I've already put this my AC to show the location already. Then this guy will now be, this is the last one, then now be DP14. I have DP14 here. I have DP14 here, DP14 here, DP14 here. So let me just show you on the load schedule how it will look like. So on my load schedule, so as you can see, we have AC indoor, 1, restaurant, that's 5. Those are the circuit that I do, just like the way we did for power socket, that we say 1, 2, 3, we count it, that's 5. The ones for lounge, that's 3. The ones for games room, that's 7. So that's how you now put it there. One circuit, right? It's one circuit, one circuit, one circuit. Cool. So, good, good, that's good. So going to the outdoor now. Let's now start from this. Let me not use this one that has 2 pair. Let me start with the last one so that you get it. Okay, good. So I said this is the name of this guy, right? So if you copy this guy now, you copy him and you go internet and you paste and you say catalog. So catalog is something that will give you the full detailed information about the particular thing you're working on. So that this is a catalog, so many products, so that it will not waste my time, I just press Control F. That's fine. Then okay, just like this. Let me try to explain this. For our normal lighting, what is the cable that we use? Yes, cable size. Lights. Yes, 1.5 mm. Do we agree? What about for socket? Now, if you use 2.5 to connect light, will it work or not? But you know that nothing bad will happen. But what is now the minimum 1.5? So they are saying the cable that means what it means is that this is like the maximum current for this thing, for that cable. If the current of the cable you are using is less than this, there will be overheating, because it's like another way we can say that the maximum current that this guy can ever consume is this. Do you get it? Like the maximum current this outdoor can ever consume is this. But that doesn't mean that is the current is consuming. The current is consuming with anything less than this, but this is the maximum. So if you are using this to calculate your load will be higher than what is needed. You get it? Do you finish? So let's now take one. Now let's use this one. Okay, according to this, right? So according to this is 15.3, right? Okay, so let's now calculate it. So to now calculate it now, we use three-phase power. Three-phase power calculation is different from single-phase power. Single-phase power is just what? What's P is equal to RV, thank you. But three-phase power, P is equal to what? Okay. So what is our root 1.732 multiplied by our current, that's 30.2. What is our V? Voltage. Three-phase voltage. Oh yeah, what's our three-phase voltage? It's 400 now, not 400. You standardize it to 400. What's our single-phase voltage? 220 or 240. Okay, so what is our cos theta? What's the name we call cos theta? What's the name in power factor? So yeah, let's multiply it. 16. So let's just say 16.7 kilowatts. Now, when we get this thing, when we use this guy, what do we have? 15.3. So what it means is that the outdoor is consuming 15.3 kilowatts on the normal operation, but the maximum that the guy can never consume is 16.7 kilowatts. So in case you didn't see this particular stuff, if you use it, the load will just be a little bit higher. So therefore, at this point, we've been able to solve our load for our outdoor. This sorted, this sorted, this sorted. You get my point? Now, what about our indoor now? So far, we saw this one out. We've already got number 5, 37. That one is fine. So how do we go about it? This is how we go about it. So for example, if you look at this now, this is for restaurant, right? So let's look at the outdoor. I mean indoor. Okay, let's try something. Let's copy the name of the indoor. Let's go there. Now mind you, for VRF, always if you are downloading, you download for Africa. So they have for East and Africa. Don't go and download it, the value will be different. So as you can see, now I said that the indoor, yeah, single phase. So just as I always say, don't say they said single phase. You can always verify yourself, say this is 22 equal to the other. You can always verify yourself, and just like that, you get but however, here is I want to know something. Please don't confuse cooling capacity to power consumption. They are two different things. Do you get it? Okay, just like this. Let me try to explain this. For our normal lighting, what is the cable that we use? Yes, cable size. Lights. Yes, 1.5 mm. Do we all agree? What about for socket? Now, if you use 2.5 to connect light, will it work or not? But you know that nothing bad will happen. But what is now the minimum 1.5? So they are saying the cable that means what it means is that this is like the maximum current for this thing, for that cable. If the current of the cable you are using, if it's less than this, there will be overheating, because it's like another way we can say it is that the maximum current that this guy can ever consume is this. Do you get it? Like the maximum current this outdoor can ever consume is this. But that doesn't mean that that is the current is consuming. The current is consuming will be definitely less than this, but this is the maximum. So if you are using this to calculate your load will be higher than what is needed. You get it? Do you feel me? So let's now take one. Now let's use this one. Okay, according to this, right? So according to this is 15.3, right? Okay, so let's now calculate it. So to now calculate it now, we use, three-phase power. Three-phase power calculation is different from single-phase power. Single-phase power is just what? What's P is equal to RV. Thank you. But see, three-phase power, P is equal to what? Okay. So what is our root 3? 1.732 multiplied by our current here, that's 30.2. What is our V? Voltage. Three-phase voltage. Oh yeah, what's our three-phase voltage? It's 400 now. It's now 400. They've standardized it to 400. What's our single-phase voltage? Hmm? 220. Okay, so what is our cos theta? What's the name we call cos theta? What's the name? The power factor. So yeah, let's multiply it. 16. So let's just say 16.7 kilowatts. Now, when we get this thing, when we use this guy, what do we have? 15.3 kilowatt. So what it means is that the outdoor is consuming 15.3 kilowatt on the normal operation, but the maximum that the guy can ever consume is 16.7 kilowatt. So in case you didn't see this particular stuff, if you use this, your load will just be a little bit higher. So therefore, at this point, we've been able to solve our load for our outdoor. This sorted. So as you can see, now I said earlier that the indoor they are single phase. So just as I always say, don't say they said it's single phase. You can you can always verify yourself. See, this is 220 to 240 volts with the other. You can always verify yourself, and you just on internet start it, press the code, you get it. But however, hey, please, I want to know something. Please, don't confuse cooling capacity to power consumption. They are two different things. Do you get it? Please don't. This is cooling capacity. This is what do you mean by cooling capacity? When you want to size a space, you want to determine the size of AC for a space. This is what you calculate, and whatever answer you get, you come here and check it. Let's say you get 5.7. Okay, you see the same thing that I did before. So they are not giving us it. So how do we go about it now? So this is how now to go about it. If you look at all this outdoor, you check their current, which is that this is it. This is what I was telling you before. MCA, minimum circuit ampacity, which means specify the lowest ampacity can have while still being able to handle the equipment expected running, blah blah blah. So we have 0.6, we have 3.4, we have 6.4, we have 6.4, we have 6.4. So what I will just do is what? I will choose and use it for the other. If I choose the highest one, that means it has covered for everybody. So oh yeah, somebody should now calculate. So I'll be using 6.4 amps. So what would be my power? 220. 1.4. So that's what I'm using for restaurants, right? That's 1.4 for restaurant. This one too. The highest is 6.4. 1.42. Then this, what is the highest?